Hello, geometry guys. This is Mr. Heeren talking to you about how to prove lines parallel. So just kind of backing up just a hair, when you're thinking about, if I told you two lines were parallel and they got cut by a transversal, you could tell me things about the different angles. All right, you would know that some are going to be, some are going to be congruent, some are going to be supplementary, so you're going to know all those things. Well, now we're flipping it around. We're saying, I don't know the two lines are parallel. All right, I don't know the two lines are parallel. All that I know is a couple of things about the angles, and from there, is that enough to tell me that the lines are parallel? So I'm switching gears. I'm kind of changing direction. I'm going exactly backwards. All right, so what I'm saying is, if um, if I know this about the angles, can I say the lines are parallel? All right, so start with simple. Now, corresponding angles. Let's take a look at this quick. If A and B were parallel, we could say that all sorts of angles were congruent. But remember, we don't know that they're parallel. What we're saying is this. We're saying we don't know the lines are parallel, but if we can prove that one set of corresponding angles are congruent, so if I can somehow show that 6 is congruent to 8, or I can somehow show that 2 is congruent to 4, if I can prove one of those situations, then I can say, yeah, those two lines are congruent to each other. But only if that is the case. So if I can say this, so let's take a look. Is it possible to prove A, B, C, any of those are parallel to the other ones, given just angle 1 is congruent to angle 3? So angle 1 is congruent to angle 3. That's all I know. Well, here's what I'm going to say. I can say, yes, A and B are going to be parallel because of converse of corresponding angles. All right, the converse of corresponding angles. So we'll talk a little bit about what converse means. So that is all I can say, though. Now, technically, I can say, yeah, 2 and 3 would be supplementary because this makes a line. So 2 and 3 would be supplementary. But I know nothing about 2 and 4, and I know nothing about 4 related to 3. I don't know anything about that. Nowhere does it say B is parallel to C, so I don't know anything about angle 4. So the parallel postulate. So kind of just a quick thing to think about, and on some level I really hope it makes sense. If you have a line and you have a point not on the line, there is only one line through the point that is parallel. So there is only one line through P parallel to M. Only one. All the other lines are eventually going to hit line M. Any line you could draw except the parallel one is going to eventually hit line M. So there's one line and one line only. So likewise, this carries over to what else we've been talking about. So the alternate exterior angles converse. Same kind of idea. If I can show that one pair of alternate exterior angles are congruent, then I can say, yeah, those two lines are parallel. All right, remember, that's the big idea. We're trying to show, how can I show two lines are parallel? Well, same idea with interior angles or consecutive interior angles. Remember, consecutive interior angles have to be supplementary. So if I can show that angle 4 and 5 add up to 180, then I can say, yeah, those two lines, P and Q, are going to be parallel. All right, but I've got to have some sort of information or have some way of proving it. I can't just look at it and say, yeah, they're parallel. No, that's not how it works. You've got to show me. So the last two, alternate interior angles, if I can somehow say 6 is congruent to 8 over here, then I can say, yeah, P is going to be parallel to Q. But only if I can somehow show that those two are going to be congruent. Remember, consecutive interior angles or same side interior angles are going to be supplementary, Everything else is going to be congruent. So now, what if I've got a perpendicular transversal? Perpendicular transversal. If two lines are perpendicular to the same line, then they are parallel. So notice, both P and Q are perpendicular to whatever that letter that is. Looks like a weird looking R, but I don't know. So if they're both perpendicular to R, then they are parallel. That is a perpendicular transversal converse. So take a look. Can I say any of these lines, L, M, and N, are parallel given just the information on the left? So number 2, I'm given 1 is congruent to 6. All right, I'm told 1 is congruent to 6. Well, let's look at 1. Let's look at 6. Well, let's see. 1 and 6 are both exterior angles. They are on opposite sides of the transversal, so they would be alternate exterior angles. But here's the thing. All this shows me is that L and N are parallel. That's it. I basically completely skip over M. That is all I know. So now let's take a look at number 3. 2 and 3. Well, they are on opposite sides of the transversal, but they are interior. In fact, they would be alternate interior. So that's going to be the converse of alternate interior angles theorem. And I'm going to say L is parallel to M. That is all I can say. Let me rewrite this. This is not M. This is N. So this, 2 lines intersecting 2 other lines. Let's see if we can show anything is parallel to anything else. So now, angle 2 and angle 8. So let's look at angle 2 and angle 8. Where are they located with respect to each other? Well, if I let L be the transversal here, L is my transversal. Angle 2 and angle 8 are going to be alternate interior angles. If angle 2 is congruent to angle 8, then I'm going to say, yeah, A is parallel to B. Notice I have 2 and 8 up here. I have nothing to do with M right now. As far as I'm concerned, the M line doesn't exist. All right, this does not exist right now for number 4. I'm just looking at the top part. All right, so for that one, A is going to be parallel to B. So number 5, 3, and 11. Okay, so for right now, I'm not looking at B at all. Right now, I'm just looking at just this piece. 3 and 11 are in the same spot. They're corresponding. They are congruent. That means I can say L is parallel to M by the corresponding angles, converse of the corresponding angles theorem. All right, A equals, for number 2, 2 and 8, that's going to be the converse of the alternate interior angles theorem. Number 6. Well, let's get rid of this. For number 6, switch colors here, angle 1 and angle 15. Okay, angle 1 and angle 15. Everybody tries to swear up and down that those two are alternate exterior angles. No. 1 and 11 would be alternate exterior angles. 15 and 5 would be alternate exterior angles. 15 and 9 would be alternate exterior angles. 1 and 7 would be alternate exterior angles. But 1 and 15 have got nothing in common. Nothing. They do not fit into any of the types of angles that we've talked about. So you have none. There is no set of lines you can say is parallel to each other by just that piece of information. So take a look. There's a ladder. Each rung is perpendicular to the 2 rails. Is it possible to prove that the 2 rails are parallel? And if that all the rungs are parallel? If so, explain how. If not, explain why. So you've got a ladder where each rung is perpendicular to the 2 rails. Is it possible to prove that the 2 rails are parallel? Is it also possible to prove that the 2 rungs are parallel? The answer is yes. The rails are parallel because consecutive interior angles is going to be supplementary. All right, so if this is 90, this is 90, this is 180. So that's going to be the converse of consecutive interior angle summary theorem. All right. Now the flip side of that is, are all these things parallel to each other? The answer is yes. The rungs are parallel by that one we talked about, by the perpendicular transversal theorem, which remainder says if two things are perpendicular to a line, they are parallel to each other. So if two lines are perpendicular to the same line, they're parallel to each other. All right, so take a look. In order to move a straight line with maximum efficiency, rowers' oars should be parallel. Is it possible to prove that any of the oars are parallel? If so, explain how. If not, explain why not. So let's take a look. So if this is 110, this is 70. So that makes a line. If this is 80, this is 100. I'm going to say nope. No angles are congruent or supplementary. There is nothing there. There is nothing there to show me, yes, these two are parallel, or no, these two are not parallel. Well, there's nothing to tell me, yes, they are for sure parallel, because no two situations are either congruent or supplementary. So no, that doesn't work. That's all I got. Come talk to me if you got questions. Be ready for a test coming soon.